Hello my dear students, good morning to you all. So in my last class I was explaining about what are the two different types of errors in analytical chemistry. That is the first one is determinate errors. What is meant by determinate errors and how do we classify them further into instrumental error or methodic error or operative error. So, how it happens, okay. So, these three errors, instrumental error, how the instrumental error will be implied into the calculation or the experiment, and how we will do methodic errors, and what is meant by operative error, or in other words which is called as personal error, and how to minimize these determinate errors. Okay, so what are the different steps which we can take to minimize these determinate errors? So that was explained, and further what is meant by indeterminate errors, and how to come to the conclusion, because indeterminate errors, so these are the errors which cannot be determined or predicted. Okay, so that is why, so these errors are also called as random errors or accidental errors. So, it is very difficult for us to control, it is not in our control to avoid or minimize the indeterminate errors. So, that is why we use some sort of statistical calculations or mathematical and statistical tests before accepting and reporting the values which are observed or which have indeterminate errors. Okay. So, some of the important terms which are used are as follows, like mean, median and range. Okay. So, how do we come to the conclusion, or how with the help of mathematical and statistical tests we are going to calculate the mean, and what is meant by median, what is range. Okay. So, the difference between the maximum value and the minimum value of the set is called as range. Okay. And then we understood what is accuracy. The accuracy of the measured value may be defined as the nearness of measured value and expected or true value. Okay. And later on we stopped in discussing or understanding what is meant by precision, where precision is the agreement between the numerical values of two or more measurements of the same quantity. Okay. So, this is where we stopped in our last class, and in this session we are supposed to discuss about so how the precision of a datum can be expressed by various different methods. Okay. So, among various different methods, so first let us understand what is meant by mean deviation, or it is also called as absolute method. Okay. So, in absolute method the precision is expressed in terms of deviation from the mean, that is x naught minus x bar. Okay. So, this x bar, this is x bar without considering the sign. For example, if you take an example of the percentage of carbon in an organic compound which was determined in terms of replicate. So, these are the following datas. Okay. So, first what we have to do, we have to find out the mean. Okay. So, here the mean is 38.26. Okay. So, if you add all these set of data what we have obtained and divide it by 5, so that gives the value of mean. Okay. So, what is the result I am going to get is 38.26 is the mean, and mean deviation means so what is the difference between this value, mean value, and the each value which is present here. So, that is what is called as deviation from mean. So, if you subtract 38.26 with 38.41, you just neglect the negative or positive signs, whatever you have to report it in a positive numericals only. So, here if you subtract 38.26 minus 38.41, you will get minus 0.15. Forget about minus negative sign, just write it down 0.15. In the same way do for all the other 4 results what we have got. So, that gives us the deviation from mean. So, next what is meant by mean deviation? So, this is just a deviation from mean. So now I have to calculate mean deviation. So then I have to add all the differences between this value and each value. This is mean and these are the individual values. What is the difference? Sum up all the 5 values and divide it by 5, that gives you the mean deviation. Okay, so this is how we are going to calculate mean deviation or absolute deviation. So the mean deviation or average deviation is very small. Okay, if you observe here, so this value 0.092 means it is very small value, hence the value are precise. Okay, that means the value is more precise. So here I can make one statement, that is smaller the mean deviation, greater is the precision of the values. Okay, this is what is mean deviation. Next, moving on to the next method of expressing precision is relative deviation. So sometimes a relative method for expressing precision can be used. Relative method means so the relative deviation of a set of values is given in terms of percentage. If we express it in terms of percentage, then it is called as relative deviation. Let us take the same example. In the above example, for first measurement, the relative deviation, the first measurement is 0.15. So this is the mean deviation. So 0.15 into 100 divided by 38.26 is equals to 0.42 percentage. So this is the relative deviation. Just we are calculating the percentage of each deviation. So this is the first measurement, first mean deviation measurement. So that I am calculating in terms of percentage to report it in relative deviation. Understood? And next is a range. What is meant by range? So the precision of a datum can also be given in terms of range, which is symbolically represented as omega. So smaller the value of range, higher is the precision measurement. So in the above experiment or example, so what is the largest value? So what is meant by range? So in my last class I defined a range is the difference between the maximum value and the minimum value of the set. So in this experiment, this is the example. So what is the largest value here? So the largest value is 38.41. And what is the least value? Least value is 38.07, right. So the same example I am taking here. So range is equals to 38.41 minus 38.07. This is equals to 0.34. Okay. So in this way we are going to calculate range. And next is a standard deviation. So this is very important, as I said in my next last class. So the standard deviation, it is the square root of the mean of the squares of the differences between the individual measured value and the mean of the difference between the individual measured value x naught and the mean of the number of measurements. Okay, so this is how we are going to define standard deviation. If I represent it in terms of mathematical equation, so standard deviation is symbolically represented as sigma. Okay, so this is the symbol which is used to represent standard deviation, and sigma is equals to, as I defined just now, it is the square root of epsilon into x naught minus mu the whole square divided by n or n minus 1. Okay, so standard deviation is represented in terms of mathematical equation as sigma is equals to square root of epsilon into x naught minus mu the whole square divided by n. Okay. So here n is the number of measurements made. Okay. So this n, it is the number of measurements made, and x naught is the individual measured value. X naught is it means observed value. O means observed, x means value, observed value. Okay. So or it is also called as x naught is the individual measured value, and mu. Okay. So what is mu here? Mu is the difference between the individual measured value and the mean of the number of measurements. Okay. So this is what, okay, in this slide it is there where n is the number of measurements made and x naught is the individual measured value and mu is the difference between the individual measured value x naught and the mean of the number of measurements. So this type of standard deviation is known as population standard deviation. So this is known as population standard deviation. So the population standard deviation is calculated only when a large set of measurements are available. Okay. So this equation of standard deviation will be used only when there is a large set of data or large set of measurement is there. So then only we are going to use this equation to calculate the standard deviation. If all measurements are not available and if random sampling is used, so then the standard deviation of the population is calculated as S, then we call it as S, then the standard equation or standard deviation is represented as capital letter S, which is equals to the square root of epsilon into x naught is the observed value or measured value minus x or mean, this is x bar, okay. So again this is x bar, x naught minus x bar to the whole square divided by n minus 1, okay. So this is the equation used when there is a measurement which is not available and if random sampling is used, so then we are going to use the standard deviation of the population by using this mathematical equation, okay. So this is all about standard deviation, and in this equation also, okay. So this equation, so n means the number of value of measurements and x naught is the measured value as I said, and x bar, so this is x bar is the mean of the sample values, and the symbol S is used instead of sigma, okay. So as I said, so here S is used, capital letter S is used instead of sigma to indicate that the standard deviation obtained is only on approximation of the true value. Okay, so it is made only in approximation of the true value. So this is also called as the estimated standard deviation or sample standard deviation. Okay, so now you understood two different types of standard deviations. That is, so the first one is population method of standard deviation, okay. So population standard deviation, so in which so we are going to use this equation, that is sigma is equal to square root of epsilon into x naught minus mu to the whole square divided by n, whereas for the sample standard deviation or estimated standard deviation we are going to use this equation to calculate standard deviation, okay. So I hope you do not have any doubts in this, and even if you have, you can clarify it once you come to the college or in the Google Meet class. So next, moving on to the next slide, what is meant by coefficient of variance? So coefficient of variance is another way of representing precision of data in terms of coefficient of variance, and it is given by, so CV. So CV means coefficient of variance, which is equals to standard deviation divided by mean into 100, okay. So it is just like we are converting the standard deviation and mean what we have converted in terms of percentage. So that is why we are using CV is equals to standard deviation divided by mean into 100. So let us take one example so that it will be more clear for us to understand the standard deviation and also what is the mean. Mean we have already understood, so how to calculate the mean, what is meant by mean deviation or absolute deviation, all these things we have understood. But standard deviation, today in this session only we understood what is meant by standard deviation and what is meant by coefficient of variance. So it will be more clear for us if we take an example and calculate the standard deviation and mean as well as coefficient of variance, okay. So what is the example I am taking here is an analyst analyzed the sample of platinum spectrophotometrically and obtained the following data for the concentration of platinum in ppm. So what are the data he has got is 19.8, 20.2, 20.1, 20.3, 20.4, 20.5 and 19.9. So he has carried out 7 measurements or 7 trials. So here the number of trial is 7, and he has observed or noted down the concentration of platinum in terms of ppm. So we have 7 different concentrations of platinum. Okay, so all these experiments were conducted by using spectrophotometry. So that is why in the example it says that an analyst analyzed the sample of platinum spectrophotometrically and obtained these many data in terms of ppm. Okay, so this is the concentration. So as I said in my last class, so first we have to calculate mean. Okay, so mean means x bar. So this is x bar. So correct it. If you keep your textbook in front of you while listening to my explanation, definitely you only can make out all these corrections. Okay, so here this has to be x bar. This is not x. This is x naught because this is observed value or measured value. This is x naught, this is correct, this is x bar. Okay. So as I said, how you are going to calculate mean. So mean or average value is obtained by dividing the sum of set of replicate measurements by the number of individual determinations. So these are the individual determinations, as I said. So here we have 7 trials. Okay, so we have 7 trials. Sum up all the values to get mean. We have to sum up. If we sum up, I will get 141.2. Okay, so divided by, this is wrong, this is not 2 because here the number of trial is 7. So that is why you have to divide it by 7. Okay, so this is 2 is wrong. So 141.2 divided by 7, this gives 20.17. Okay, and next I have to calculate mean deviation. What is mean deviation? So how to calculate mean deviation? So subtract this value 19.8 minus 20.17 is equals to 0.37. So 20.2 minus 20.17 is equals to 0.03. You can check it out. You can take the calculator and check it out while listening to this class. Just pause and calculate yourself. 20.1 minus 20.17 is equals to 0.07. Okay, so in this way we are going to calculate mean deviation. Okay, so again I am saying, so this is x naught minus x bar, not x naught minus x. Okay, this is mean deviation means observed value minus mean. Okay, so mean is x bar, so that is why x naught minus x bar. Find out all the values for mean deviation using this individual values and this mean value. Okay, and next is so what you have to do is x naught minus x bar to the whole square. This you have to square up. Okay, so these values should be squared up, so then you will get these values. Okay, so check it out by using the calculator before you go to the final value. So epsilon x naught minus x bar to the whole square means, so add all these individual values of x naught minus x bar to the whole square. So that gives epsilon x naught minus x bar to the whole square. Okay. So now I have got all the values which is required to calculate the standard deviation. So what is the equation for standard deviation? S is equals to square root of sigma into x naught minus x bar to the whole square divided by n minus 1, right. So here I have calculated epsilon or sigma x naught minus x to the whole square value. So that is 0.394. 43. Okay, so substitute that value. N minus 1 means n is the number of measurements made. So number of measurement made is 7. 7 minus 1 is equals to 6. Calculate this. So this is the standard deviation. So I have calculated standard deviation and the value is 0.2563. Okay. So again I have already calculated what is mean. So mean is 20.17. So here you can see 20.17 is the mean value, and median is the central middle value, so that is 20.2, and range is the highest value minus lowest value, that is 0.7, and I am calculating coefficient of variance. So as I said, coefficient of variance is equals to standard deviation divided by mean into 100. Standard deviation we have calculated here, 0.2563 is the standard deviation divided by mean is 20.17 into 100. So this is equals to 1.27 percentage. Okay. So this is how we are going to calculate coefficient of variance. Okay. And in my next class we will see what are the significance of tests and we conduct various different tests to again these tests are used as a statistical tests to compare individual values or set of values of significance differences. Okay. So, this is why or this is the importance of conducting various different types of tests. So, in analytical chemistry, so we conduct 3 tests, so that is one is a Q test, F test and another one is a T test. Okay. So, what are these Q test, F test and T test, how we are going to calculate it. So, all these things we will discuss or I am going to explain in my next class. Okay. So, to summary of my class in this session was so I explained about what is meant by precision and with the help of precision how we are going to calculate a relative deviation and what is meant by range. Okay. And before that what is meant by mean deviation or absolute method, and we also understood what is meant by standard deviation and what are the 2 types of standard deviations we are going to see. So, that is the first one of standard deviation which is known as population standard deviation, and another is estimated standard deviation or it is also called as sample standard deviation. And next we understood what is meant by coefficient of variance. So, all these concepts or mathematical equations were clearly understood by taking the example of an analyst who analyzed the sample of platinum spectrophotometrically with 7 different measurements and we calculated standard deviation and thereby we understood how to calculate coefficient of variance. Okay. So, I am going to stop it here. We will meet in my next class. Thank you dear students.